Okay. So scavenger hunt's Monday, so we'll just take the notes today. Okay, complex zeros. So if I have a polynomial of any degree, 3, 5, 10, 20, I wouldn't give you a 21. Of any degree we call n, okay? Why won't it click? Okay. Remember, if the degree is 3, there's 3 answers, 3 solutions, 3 zeros, right? If its degree is 5, it has 5. So if the degree is n, it has exactly n complex zeros. Okay, when counting multiplicity. Now you have to include multiplicities. One can happen twice, right? That's still considered 2, okay? Now remember, a complex is anything that is in this form, a plus bi. Okay, so complex, remember the a is the what? Real part? The bi is imaginary or non-real part. Okay. So complex includes real and imaginary. Now, if we have a non-real one or imaginary, remember when you're solving, like, if you got imaginary, there was always plus or minus, right? So if you cannot have one imaginary number. They have to come in pairs, okay? So if I have 2i, I know that negative 2i is an answer. They come in pairs, okay? So if they're non-real zero, they always come in conjugate pairs. And we'll talk about conjugate in a minute. You guys remember? Okay. So that means you either have none or an even number of non-real zeros. You can't have 3 imaginary answers. It's not possible, okay? So you either have no non-real zeros or an even number. Okay. Imaginary, or even when you guys do the square roots, they come in a pair. You guys remember quadratic formula? It was the plus or minus, right? They always come in pairs there. Okay, we all good here? Okay, let's look at this one here. So what does it mean to be a conjugate? If you have a non-real one, that's a plus bi, right? Anybody remember what the conjugate of a plus bi is? What does the word conjugate tell me to do? You change the operation, right? So it's just a minus bi. The first one does not change. It's the imaginary one that changes, okay? So if I have 2 minus 5i, the conjugate is what? 2 plus 5i. Okay. You just change the imaginary part. If you have negative 6 minus 7i, you do not touch negative 6. It's just the imaginary part that changes. Okay, so its conjugate is negative 6 plus 7. Because remember the quadratic formula, it's negative b plus or minus square root. That negative b never changes, correct? It's always so. That number should stay the same. Okay, so let's talk about these solutions and how they occur. Okay, so this one's degree 2. It's a quadratic, right? So that means I have what? 2 zeros, 2 x-intercepts, 2 roots. So this is the only 3 things that can happen. What do we have here? There's 1 here and 1 here. So how many real zeros do we have? 2. And we have what? No real, no imaginary. Okay. Now looking at this one, how many x-intercepts do we have? 1, but this actually gives me 2 of my zeros. Why is it? Because it's what? Tangent? And if it's tangent, if it touches that thing, it tells me it's what? Multiplicity 2. It happens twice because it touches it, right? It's a bounce. So do you have any here? Now this one, the third one, does it touch the x-axis? No, so this one has what? No real zeros? And when it doesn't touch it, that is actually your imaginary one. You have 2. 2 imaginary, non-real, whatever. Okay? When it doesn't touch that. So quadratics, you can have 2 real, 0 imaginary, or 2 imaginary, 0 real. That's all you can have, okay? Now let's look at cubic, okay? Cubic is what? X cubed, blah, 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 right? So this one is how many? 1, 2, 3. So this one, 3x intercept means there's what? 3 reals, and this one has none. Now look at this one. How many times does it touch the x-axis? 1, right? So we have 1 real. Now, do you guys see how it's turning up here instead of down here? Like the first one turns down here and touches it, right? This one turns up here and doesn't touch it, right? That tells me that I have imaginary ones in there. So I know I need to have what? 3, right? So I have only 1 real one. So what does it tell me? I have 2 non-real. Okay. Okay. How many do I have on this one? There's this one, right? But I only see 2. How come I don't have 3? I said imaginary ones need to come in pairs, right? So I can't have 1. How come I only have 2 x-intercept? So what does this tell me right here? It's a multiplicity of 2. So it actually happens twice, correct? So that's where I get the third one from, okay? So this one has what? Multiplicity 2. This one has what? Multiplicity 1. So that gives me my 3, okay? Now you have a little bit room. They didn't write this one in, and I want to write this one in. So draw this one here. That is also, that's a graph of x cubed by itself, okay? How many x-intercepts do we see? 1. But what do I know about this one? Multiplicity, it does the point of inflection or a little bit. So this one has what? Multiplicity 3. And I'm sorry, I didn't write it. This one has none and this one has. Okay. Okay. Any odd one, you guys, all the odd, you must have 1 real one. All odd degrees must have 1 real one. Because I said imaginary ones come in what? Pairs, right? So if you're coming in pairs, 2, 4, 6, there's no way to get an odd number, right? So all odd degrees must have 1 real 0. And that should just make sense, right? Because if the imaginary one comes in pairs, to get an odd, you got to have 1 left over. Even ones, do you need to have a real one for even one? Can they all be imaginary? Yes, right? So here, like I had that right there. These were 2 imaginary, right? So even can have all imaginary, but odds can't. Okay. Okay, we ready? Okay. So odd degrees must have 1 real, even ones don't. They can have all imaginary. Or non-real, whatever you want to call it. We all good here? Okay. Anybody else? Okay, I typed that in. So let's look at example 1 here. The polynomial is given by this function. So what do I know? The degree is what? 3? If it's 3, what do I have? I have 3 zeros, correct? And x-intercept, Linda, go to the green part. The notes are over there. Where you been? On the top, is there any left over? It says, I can't see. It's 1.5b? 1 point, is it? Yeah, we're below the graphs now. Okay, 3 zeros, right? So what did it tell? So it tells me that the x-intercept is what? Another word for 0, yeah, is 1.7. So if 2.3 minus 1.5 is a 0, what do we know about the other solutions to that? Okay, so I know I have what, 3 zeros or 3 solutions for this equation here. So what do I have? I know there's one real. What's my one real? 1.7, right? And what do we have? 2 non-real or 2 imaginary? And what are my 2 imaginary? 2.3 minus 1.5i and 2.3, the conjugate plus 1. They have to come in pairs. Who's this from, Linda? Okay. So, and this is just a review. I should have put this first, but what are conjugates? All right, we changed the what? Imaginary part. So what is a conjugate of 4i? Negative 4i. What's the conjugate of negative I? Positive. What's the conjugate of 2 minus 3i? Plus 3i. And what's the conjugate of negative 4 plus 2i? Well, minus 2. Okay. What's the conjugate of 5? Just 5. There's no imaginary. Conjugate of 5 is 5. Okay. All right. So here we go. This is the fun part. Okay. We're going to start solving finding all the real and imaginary. Okay. So find all real and imaginary zeros. Okay. So first of all, my degree is what? 4. So I should have what? 4 solutions or 4 zeros, right? 4. Now out of the 4, I can have what? 4 real? Don't write this down. Can I have this? Is that a possibility? Can I have 3 real and 1 imaginary? What did I say about imaginaries? They come in pairs. So can I have 3 real? So that's not an option. They have to be even. Imaginaries are, can I have this? Yes. Can I have this? No, right? Imagine, and can I have this? Yes. Those are the ones we're allowed to have, right? So there are ways to tell, maybe I'll do it. Okay, so let's look at this. So factoring, when you see these, I'm not going to tell you how to factor it. You have to look at it and be able to think of what method, right? This is an x to the 4th, so I could either go to synthetic division, but that's 20. 1, 2, 4, 5, 10. That's a lot of things to try. You have to recognize this one. Does anybody recognize what I can do with this one? Is I can do the x factor. This is in what? Quadratic form. Why? What did I say? It's half of that, right? So this is what? Quadratic form. You have to be able to recognize these. I mean, you can do the synthetic, but you're going to be sitting there for a long time sometimes. Okay? So it's quadratic form. So what can we just use? 20 and what? A times C and B? What multiplies to 20 and adds to 9? 4 and 5, right? So now A is 1, so I don't have to worry about it, right? So, and some of you go to grouping, which I'm totally, some of you write this as 4x squared and 5x squared and group. If you want to do it that way, you do it whatever you like. Okay, you got to pick your own way. So what do we have now? What do I put in my parentheses though? This is plus 4. This is what? Plus 5? Do I put x and x there though? It's x squared. Why? I need to end up to x to the 4. So what do I put here? It's always your middle term, x squared. And I'm trying to find the what? The zeros. So I set this equal to 0. Okay, can I factor x squared plus 4? What? Huh? No. Some students want to do this because they say, well, this, if I just, you cannot distribute that in there. You're only allowed to distribute that when I have no one term, not a plus or minus sign. If I had squared here, you can go 4 and 6. Okay. But if you think about what this means, this says I have 2 of what's inside here, right? If I do this, this is actually this. My biggest pet peeve on stuff. People put that x squared plus 4, that's it. And what does this multiply to? X squared plus 2x plus what? 2x plus 4? That middle term does not, that does not equal x squared plus 4. Okay? And so this is called a sum of squares. Sum of squares is not factorable. Okay? There's nothing you can multiply that'll give you like nice numbers. You got to have some, you can use we could factor this, but I have to use imaginary numbers. Okay? How about this one? Is that factorable? 5 x squared? No. So how do I solve these? Well, just says if I have 2 factors that multiply to 0, what does it mean? One of them has to equal to 0. That's the only way I can multiply to 0, right? So that's our 0 product property. So what do we have here? X squared plus 4 equals 0. And x squared plus 5 equals 0. So get x by itself, subtract 4 to both sides. X squared equals what? Negative 4. How do I solve this problem? What do I do to solve x squared equals something? Square root of both sides. Square root of x squared is that. What's square root of negative 4? 2i, right? And what do I need? Remember we said they come in pairs, right? What do I have to put? When you take square root of both sides, you have to put plus or minus. Okay. So coming back from last year or 2 years ago, if you had trig last year. Okay, so how do I solve this one? We minus 5 to both sides. So what is x squared equal to? Well, negative 5. And then what do we do? Square root, square root. So what is x equal to now? Plus or minus? No. Not square root. That's not, this is not right. It's negative, correct? Can I take square root of a negative number? I. Yeah, need an I. If you remember, definition of I is what? Square root of negative 1, right? What is I squared equal to? Huh? Negative 1. I is the only number when you square it that is imaginary. Okay. You cannot go square root of, you can't go square root of negative 1 times square root of negative 1 is a positive 1. You can't do that with I. That's square root. Okay. All right. So what did we end up with here? How many solutions? 4, but they're all what? Imaginary, non-real. So if I were to thinking about this graph here, that means it never touches the what? X-axis. So it's somewhere. Somewhere. Okay. It touches 20. That's why I moved it over. All right. Next one. Okay. It's a what? Cube. So cube. What does this tell me? I have what? 3 solutions, right? So I have 3 zeros. Can we have all real? 3 real? Why not? 3 real? Can I have 3 real? Can I have 1 real and 2 imaginary? Can I have 2 real and 1 imaginary? No. Can I have 3 imaginary? Imaginary has to come in pairs? No good. So you only have 2 choices there, right? Okay, let's go ahead. How am I gonna solve this one? How do I what do I do to this one? Is that quadratic form? No, huh? We're gonna try grouping, right? If grouping doesn't work, what would I have to go to next? Synthetic, okay, so let's hope group works, right? So let's look at these two. What can I take out of the first two? X squared. And what are we left with? X plus 1. What can I take out of the second group? -9, and we're left with what? Oh, it does work, thank goodness. Okay. So I can factor out an x plus 1 oops, no. Then what are we left with? X squared minus 9. You could stop here, but I'm going to factor because I like factoring more. And can x squared minus 9 be factored? That's our difference of squared. That's a squared minus b squared. So this breaks down to what? X minus 3. Some of you stop when you see that. You don't all factor that down. I'm not going to write the next step. I'm okay if you just tell me what the answers are. -1, 3, and -3. I'm okay with that. Okay. You don't have to write. If you can do it in your head, just do it in your head. So what did we get? 3. Here we got, sorry, I was gonna write. We got 4. We good? Okay, next one. What am I gonna do to help me solve this? What method? Synthetic, right? Synthetic, I have to find the list of possible ones, right? So what are my possible zeros gonna be? My possible rational? Where do I get my list from? Which ones do I look at? Negative, right? The last term? In some books, they'll say P over Q. P is the last one, Q is the first one, okay? So what are they? Factors of 2? Does it matter that it's negative? No, because we put plus or minus in front of everything anyway, right? So what do we have? 1 and then where do I get my denominator from? First. The leading coefficient, right? So which is what? 4. So what are factors of 4? 1, 2, and 4. So what do? I take everything in the top and divide it by everything in the bottom. So 1 divided by 1 is 1, and I put plus or minus it. 1 divided by 2 is 2. And 1 divided by 4 is, I'm sorry, 1 divided by 2 is a half. 1 divided by 4 is 1/4. And then what do? I take 2 and divide by everything. So 2 divided by 1 is 2. What's 2 over 2? Do I have 1? I'm not going to write it again. Okay. And what is 2 over 4? 1/2. Do I already have a half? I'm not going to write it again. I don't do the fractions until I exhausted all my whole numbers. Okay. What do you guys want to try? 1, 2, pause, or -1, -2. I don't care. Somebody shout out 1. 1. Okay, I heard 1. So let's try 1. So what do we have here? 4, -8, -3, 7, and -2. Does this work? 4, 4, -4, -4, -7, -7, 0, 0. Does that work? No. Okay. So what do you guys want to try next? -1, huh? -1, 4, -8, -3. What is this? 4, -4. What is that? -12? 12, 9, -9, -2. Oh, did we find one? Okay. So I'm going to write that a 0 is -1, the solution, right? So let's write down, what do we have afterwards. So I'm gonna write it here. So after this worked, our factors are what? X plus 1. That comes from the negative 1. Remember, it's the opposite. And what do we have left? 4x. What power do I put 4x? What's the exponent there? Is it 4? 3, it has to go. You just factored an x plus 1 out, right? That's what you just took out. So this should be an x cubed now. It should be down 1. You just factored out an x plus 1. 12x what? Squared plus 9x. What's the last piece? Minus 2. Does everybody understand why that works? Why you go down 1? You're taking out an x plus 1. So you're dividing that out. So if you had x fourth and I divide out an x, I'm left with x cubed. Okay. So now I see there's what? 4 terms, but I can tell in my head grouping's not going to work. You guys see this is 4 and 12. I could take out a 4 and I'm just left with x. But here, what are you stuck with? A 9? Grouping's not going to work. Right? So now what do we have? Got to do synthetic all over again. Do not go back to the original problem. You're going to get a mess. If it does not show the multiplicities. So what am I going to use here? 4, negative 12, 9, and negative 2. Now, 1 didn't work earlier, correct? So it's not going to work ever again. And my numbers, these two are the same numbers, so I can use that same list again. Now, negative 1, could I try negative 1 again if I wanted to? Yes, it could work again. It's a multiplicity. So my choices are now what? Negative 1, 2, and negative 2. What do you guys want to try? Huh? Wait. Who said 1? Who? Did we try 1 already? Did 1 work? It's never going to work. If it didn't work in the beginning, it's never going to work. So do not try 1. You could. It's going to show it's not going to work. You just wasted some time. Okay. So my choices are what? Negative 1, 2, or negative 2, or one of those fractions, but I don't want to work with that yet. Okay. So what do you guys want to try? Which one? 2? Okay, we can try 2. So what do we have here? 4, 8, negative 4, negative 8, 1, 2. Oh, did it work? Yes. So now, don't forget the first one we had. What was the first one we had? X plus 1. Now, 2 is a 0, so it's what? X minus 2. And then what is this one? 4x squared minus 4x plus 1. Everybody know we go down 1 again. We took out another x. Okay. Now, should I do synthetic division again, or isn't that a quadratic? So do whatever you guys do. I'll do the x. A times c is what? 4. B is negative 4. What multiplies to 4 and adds to negative 4? Okay. So if you were in my class or Mr. Wynn's class, we do the same thing. I don't know what the other teachers do. Okay. So in my class or Mr. Wynn, what did we do? We divided by A. Remember, you always have to divide by A. So what is A though? 4. And then you have to what? Simplify it. If you don't understand this way, do it whatever if you did grouping or whatever you guys do. So what are your, I'm losing my voice here. This is what? X minus a half, right? But this doesn't actually give me that. In my class, remember this denominator has to go out to the front. Okay? So whatever way you did, what does Miss Kim do? She make you do it? Anybody know? Who had Miss Kim? What does she make you do? What's the Korean method? That doesn't help me. Did you get the same thing? Okay, do it. Anybody have Mr. Aviles? I don't know what Mr. Aviles does. Anybody have Mr. Aviles? Ms. Dang? I don't know. There's too many math algebra 2 teachers. We don't do it the same way. So some people I saw do grouping. If you like grouping, you can do grouping. Okay. If you have no way, you don't know how to get it, come see me. We'll figure out a way that works for you. Okay. So what are your answers here? Negative 1, 2. Don't these two give you the same answer? 1/2 multiplicity. Okay. Was 1/2 in my list? Yeah. Okay. You guys, if you're stuck at this, you need to figure something out, right? I don't like to review that too much because there's so many different ways everybody does it that gets everybody. You can just do that in your head. You guys can do that. Okay. We good? I think some of you do it in your head. I see on your papers. Okay. You guys try this one. How many answers should you get? 4. Yeah. I'm gonna go walk around. You get to write it for me. Don't touch the buttons on my pen. I did this last year. Oh. Oh, yes. Oh. That's fine. How come he got -3? Let's just double check. I just saw his. I wasn't there. So plus it's a -1. Okay, let's double check. No, because you read through a problem, right? Yeah. You all, I will finish on the page. You said why do you want to try to do that? Solve this one. Solve the time you put it down. Time you put it down. You do the book board before. You're in my class, you did this one. Huh? You get it in my class. Okay, did we all get the answers to real to imaginary, right? Plus or minus I square root of 3? Who's the solve it? We didn't solve it. Solve means x equals, right? I would give you that as credit. Thank you, Emma. Okay. You guys, don't just solving and factoring are two different things. Solve. You're in my class that was on. Did I give you that as extra credit last year too? Algebra 2 class?
Second law.
You root is the square root of how many answers did you get? 3. What do we say? How many answers did you get here? 3. You can have 3 real or what? 1 real and 2 imaginary. You lot of them. You don't even know. Cube root of a negative number is not. You can have cube root of a negative number. It's not imaginary. The only thing that's square root of a negative number.
Oh, yeah.
You cannot have cube. You can't cube root of a negative. Cube root of negative 8 is just negative 2. Has nothing to do with R. I have people who got it first period.
We use that formula.
One of the answers. You guys cannot, you can't do the 8 over cube root, but that only gives you one of the answers. It's for 10 extra credit points, somebody. Is that black water bottle? I don't know. Right, minus. Anybody get it? Well, you get the credit for it. Let me freeze this. Oh, wait. No, you gotta bring it on.
Are you stamping the homework you assigned last night too?
No, hold on. Let me stop recording. I have this recording what we're saying.